Hello everyone, welcome back. We have so far covered about introduction to agronomy and we were covering different meteorological aspect or weather aspect. As we have covered atmospheric temperature, atmospheric rainfall, cloud, atmospheric humidity, etc. And today we are going to discuss about weather abnormalities and weather forecasting. And we'll in next class we will cover the effect of weather on crop growth. Okay. Now let's discuss weather abnormality. So what is abnormality? Weather abnormality. What is weather and what is the difference of weather and climate? We have already discussed. So weather is the present day or present moment. What is the weather element or what is the status of weather element? I mean, what is the atmospheric temperature? What is the cloud coverage? What is the solar radiation intensity? All these things that is called weather. That means at particular moment at a particular place what is the condition of the atmosphere, that is weather, right? So weather abnormality means what? So if any sudden change of weather is happening, if any unexpected behavior of weather is happening, then that is called weather abnormality. Okay, so weather abnormality, what are the different types of weather abnormality? One can be flood, another can be drought, can be cyclone, it can be hailstorm, it can be dust storm, it can be heat wave, it can be a cold wave, it can be tornado, it can be any abnormality from the normal atmospheric behavior. Okay, so first we'll discuss the flood. When flood is happening, flood means any like excess amount of rainwater. If excess intensity of rainfall is happening, excess amount of rainfall that is moving above the soil or above the ground, then it carries different nutrients, it carries soil and it deposits somewhere else, so soil becoming less fertile and all. So when the rainfall is higher than the infiltration rate, okay, so if the intensity of rainfall is higher, one is sealing of soil pore happen, okay, then infiltration is less than rainfall, okay, so in rainfall intensity is higher than the rate of infiltration, then there is surface runoff is happening, so that is called flood or flood water. So if there is high intensity of rainfall, again what might happen, there is breaching of tank and pond, then also it will cause flood. Okay, so how it can be controlled? It can be controlled by multi-purpose dam, afforestation in catchment area, then adequate drainage facility, availing adequate drainage facility. All these things we can implement to control the flood. Then another abnormality that is called drought. Okay, so drought is crop failure due to insufficient soil moisture. It is crop failure due to insufficient soil moisture. So how drought might happen? Drought might happen, so if we cannot provide enough irrigation to the crop, or there is abnormal rainfall, so if there is delay in onset of monsoon, if there is prolonged dry spell during the crop period or early cessation of or withdrawal of monsoon, then drought might happen. What we can do to ameliorate drought situation? We can go for in situ conservation of rainwater. We can we can do some water harvesting structures. We can plant windbreaks and shelter belt. We can take some agronomic practices to overcome moisture stress in the dryland area. So in this way we can ameliorate drought. Then there are some new technology like rooftop water harvesting we can do, then water recharge we can do. Okay, so then watershed, we can follow watershed technology, right? So there are some other weather abnormalities like I was talking about. Okay, rain during fertilization, hailstorm, dust storm, cold wave, heat wave, high wind, cyclone, tornado. These are some other weather abnormalities. So you can go through textbook and you can read if you want to know more about different weather abnormality. Then let's discuss about tropical cyclone. That is also important from exam point of view. Tropical cyclone generally, why it is called tropical? Because it falls in, it occurs near the latitude, uh, I mean equator, that is 5 to 20 degrees of latitude it happens. Okay, so what are the local names of tropical cyclone? See, cyclone, it is having different names and different regions. Okay, so it is called hurricane in North America, it is called typhoon in East Asia and Philippines, it is called bakio in China, it is called cyclone in India and Australia. How it forms, how cyclone forms or tropical cyclone forms? So there is steep temperature gradient. If there will be steep temperature gradient, there will be steep gradient of pressure as well. Okay, if there is steep gradient of pressure, that means 20 to 70 millibar difference will be there. Then in center of the cyclone there will be high rise in temperature, so there is pressure drop. So when there is pressure drop in the center of the cyclone, then high fierce wind will move from outwards towards the center, and uh, that forms the cyclone. Okay, so average diameter of cyclone I, that is 23 kilometer, and if cyclone originates in water bodies and that is warmer than 27 degrees Celsius, then it forms tornado. So there are stages of cyclone. First one is assemblage of cloud. Cloud will assemble there. Then there will be drop in pressure. Then there will be depression. Then there will be storm phase or storm formation, that is 60 to 120 kilometer per hour. Then that will increase, the storm phase will increase, that is called cyclone. That there the in cyclone there the wind speed is more than 120 kmph or 120 kilometer per hour. Remember always cyclone movement in is north and northwestward up to 20 and up to 30-degree north latitude, and average than and it is reverse in eastern and northeast direction, and it moves in north eastern and northeast direction. Speed of cyclone generally 18 kilometer per hour. Then coming to sorry, then coming to weather forecasting. From the name itself you can find, so weather forecasting. So forecasting the weather, that means in near future what it is going to be, what is the atmospheric condition going to be in short period or in near future. Okay, so there are different types of weather forecasting, that might be nowcasting, that might be short range weather forecasting, that might be medium range weather forecasting, that might be long range weather forecasting. So based on what is our purpose, we can find that type of weather forecasting is suitable for us. So IMD, that is in Indian Meteorological Department, the headquarter was in Pune, established in Pune in 1875, and now it is in New Delhi. The Agrometeorological Division of IMD, that is established in 1932. Regional weather forecasting centers like Chennai, Nagpur, Mumbai, Delhi, Kolkata, and Guwahati. So in weather forecasting, we have to do proper recording of data, then carefully study the synoptic chart and search for similar situation in historic data. We have to match that. And now in the age of AI and machine learning, it is very easier. It is becoming more convenient. Okay. Now the precipitation of weather chart we have to prepare, and we have to draw or a quick and correct definitive conclusion, and we have to tell that to the farmers or to the enterprise. Okay, so this is going to be the weather situation, and you act accordingly. Now weather chart or synoptic chart, there are different weather in weather chart, we there are different symbols. So how to identify different symbol? One is isobar, that is a narrow black line with pressure in millibar. So there will be narrow black line will be there, and pressure in millibar, that is represented, and there will be some markings, that is called isobar line. Then precipitation, here there is only shading is there. When there is precipitation there is shading. Then wind direction, you can find one arrow that is showing wind direction. Then amount of clouds, some small circle with precipitation with shading, then that is representing amount of cloud. There are other wind weather chart or weather symbols, you can find it in textbook. Then satellite pictures, they generally use infrared signature, and it gives you mostly the temperature of Earth surface and cloud. Then visible signature also, it is helpful in cloud formation and movement. Sorry. Now weather forecasting information are represented like forecasting sunny, that means sky is clear and more around 90 to 100% sunshine is coming. Then partly cloud or scattered cloudiness, 50 to 90% sunshine if it is there. Considerable cloudiness if there is 20 to 50% sunshine. Then mostly cloud if it is less than uh, or equal to 20% sunshine. Then precipitation. Precipitation, when the precipitation is less than one third of the area receive rainfall, then that is called isolated precipitation. When rainfall is in area one third to two third of particular location, then that is called scattered precipitation. When more than two third of the area is receiving rainfall, then that is called widespread rainfall. Then dew, how it is being forecasted, like very light dew, moderate, heavy, very heavy, and wet dew. Then types of weather forecasting I was talking about ki nowcasting. That means if within 1 or 2 hours, if there is any weather forecasting, like there will be lightning, there will be heavy rainfall, then that is called nowcasting. Then short range weather forecasting, if there is within 1 week, if there is any casting, or 1 to 2 days, if there is any weather forecasting, then that is called short range weather forecasting. Medium range weather forecasting, if within 3 to 10 days, if there is weather forecasting, then medium range weather forecasting. Suppose there will be rainfall. So if there will be rainfall, we should harvest our crop. Then if there will be rainfall, we should plow our field earlier. Then that is called medium range weather forecasting. Then long range weather forecasting. So it is useful when we are planning something like 1 to 2 months or later than that. So then there will be long range weather forecasting. If we want to choose a cropping system or a crop for a particular location, then that long range weather forecasting will be helpful. Okay. Then methods of weather forecasting. There are different methods we use for weather forecasting. One is conventional or synoptic method, that is used basically for short range forecast. And here, based on the current situation over past development, we generally go for weather forecasting, conventional or synoptic forecasting. Then statistical method we use for both short and long range forecasting. Here multiple regressions are being used. Then numerical method, it is mostly used for medium range weather forecasting. Okay. Now weather modification. If there is any weather abnormalities happening, then we can modify that weather up to some extent, but it is not economical. So if we have, there is a chance of weather modification, we can do it. Like if we want artificial rain, then we can go for warm cloud seeding and cold cloud seeding. There is cloud seeding technology that is being used for artificial rain making. So there are two different type of cloud seeding, warm cloud seeding and cold cloud seeding. When there is positive cloud temperature, then that is called warm cloud seeding. When there is negative cloud temperature, then that is called cold cloud seeding. For warm cloud seeding, there is hygroscopic material are being used like sodium chloride. For cold cloud seeding, there are again two approaches. One is static approach, another one is dynamic approach. For static approach, 1 nuclei of dry ice or silver iodide is being used for 1 liter cloud. Okay. For dynamic approach, 100 to 1000 nuclei for 1 liter cloud air is used. That is dry ice or silver iodide. So from here you can remember important points like for warm cloud seeding, sodium chloride is being used or hygroscopic material is being used, and for cold cloud seeding we use generally silver iodide and dry ice. Okay. Now, if we want to reduce the wind velocity, we have to plant windbreak and shelter belt. If we want to protect our crop against frost damage, we can use heater, overhead sprinkler, or add sand or shelter belt. If we want to prevent our crop from heat trapping, or we want, if there is more less temperature and we want to trap the heat, then we can uh, that is being beneficial for temperate climate and adjusting canopy structure as well, or canopy temperature. Then climate classification. There are basically five grouping of climate classification. So having similar entities and objective. Why climate classification is important? To study about climate systematically and to understand general pattern and ecological condition, to estimate agricultural potential or to transfer of technology. First person to attempt climate classification was De Candolle in 1900 AD. He classified climate based on vegetation. Then first person to classify climate based on weather element, that is Köppen in 1936. He used the parameters like annual mean monthly temperature and precipitation. Then most widely used or accepted climate classification was by Köppen and Thornthwaite classification. Classification suitable for agricultural purpose is by Troll in 1965. So how Thornthwaite classified the climate? Thornthwaite classified the climate based on precipitation effectiveness index P by 100 and temperature effectiveness index, that is summation of T minus 32 by 4. Troll classified the climate based on temperature and humid months. So according to modified Troll classification, that is followed by Ecrichard, if a climate is having less than 2 number of humid months, then that is called arid climate. Then semi-arid dry climate 2 to 4.5 months, and semi-arid wet climate when it is 4.5 to 7 months, humid climate when it is more than 7 months. So according to a modified Troll classification, which is followed by Ecrichard, that is International Crop Research Institute for Semi-Arid Tropics, that is situated in Hyderabad, and it is a CGIAR institute. So, arid climate when there is less than 2 months of precipitation, semi-arid dry climate when there is 2 to 4.5 months of precipitation, semi-arid wet climate when there is 4.5 to 7 months of precipitation, and humid climate when there is more than 7 months of precipitation. Then moisture deficit index is also being used by AICRPDA, that is MDI is equal to moisture deficit index is equal to P minus PET by PET 100. So when the MDI value is more than minus 66.6, that climate is classified as arid climate. When that is minus 33.3 to minus 66.6, it is called semi-arid climate. When it is 0 to minus 33.3, that is called subhumid climate. So this was about climate classification. Now agroclimatic zones of India based on homogeneity in agro characteristics, that is, let's say, rainfall, temperature, soil, topography, farming system, water resources, and water resources, these parameter planning commission classified or delineated whole India, geographical area of India, into 15 agroclimatic zone for its better management, for its better resource utilization, right? So what are these 15 agroclimatic zone? One is Western Himalayan zone, Eastern Himalayan zone, Lower Gangetic Plain zone, Middle Gangetic Plain zone, Upper Gangetic Plain zones, Trans Gangetic Plain zone, Eastern Plateau and Hill zone, Central Plateau and Hill zone, Western Plateau and Hill zone, Southern Plateau and Hill zone, East Coast Plain and Hill zone, West Coast Plain and Ghat zone, Gujarat Plain and Hill zone, Western Dry zone, and Island zone. So these are the 15 agroclimatic zone that is classified by Planning Commission based on different agro characteristics, homogeneity in agro characteristics like rainfall, temperature, soil, topography, farming system, etc. Now, agroecological region classified by Shanghai et al. Into 16 agroecological region based on topography, climate, soil, and length of growing period. And agroecological region based on NBSS LUP, that is 20 agroecological regions are there. Now, agroclimatic zone by ASRP agrometeorology region regrouped climatic zone based on rainfall, MDI, MI, LGP, and agroecological subregion. Concept of agroecosystem in India. Agroecosystem is a function of soil, crop, animal, microorganism less sustainable than any natural ecosystem. Agroecosystem is less sustainable than any natural ecosystem. Why is that so? Because there is constant human intervention in agroecosystem. Five agroecosystems in India are classified or delineated into five agroecosystem. One is arid ecosystem, rain-fed ecosystem, coastal ecosystem, hill and mountain ecosystem, and irrigated ecosystem. So if we see arid ecosystem, the area is 38.7 million hectare, having 31.78 million million hectare hot arid and 7 million hectare cold arid climate like Ladakh and all those parts. So there is less rainfall, more precipitation, PET, though precipitation is less in cold arid. Then xerophytic plants are mostly dominant. Then ephemerals can be grown. Rain-fed ecosystem rainfall is between 500 to 1500 millimeter, PET 1100 to 1900 millimeter. So there is basically negative balance of rainfall. Erratic and low rainfall, then degraded low fertile soil is there. Then harsh temperature regime and early withdrawal of monsoon, alphisol and vertisols are most predominant in rain-fed ecosystem. Then coastal ecosystem, around 700, 500, 7,500 kilometer coastline is there. Then plenty natural resources, highly fragile ecosystem support agriculture, aquaculture, marine fisheries, agroforestry, and silviculture. Hill and mountain ecosystem, northwest and northeast Himalayan region mostly dominated. Then cold desert in Ladakh, whilst wettest place Mausin Ram or Meghalaya is there also in hill and mountain ecosystem. High altitude plantation crop are mostly being used. Then irrigated ecosystem, around 37 to 45% of India's geographical area or net zone area, that is irrigated. 56% of agricultural produce is being we are getting from irrigated ecosystem. Main problem is waterlogging and salinity. So this is about agrometeorology, and in next class we will discuss about influence of climate on crop. So keep reading, keep signing, and if you have any doubt from this particular lecture, you can let me know in the comment section. And see you in the next lecture. Till then, have a great day. Bye bye.